Alright, this is 4.3, example 431. I'm going to go ahead and read it out, and I'm going to talk us through the chart that the book has. Box 1 contains 2 red balls and 1 blue ball. Box 2 contains 3 blue balls and 1 red ball. A coin is tossed. If it falls heads up, box 1 is selected. If it falls tails up, box 2 is selected and a ball is drawn. Find the probability of selecting a red ball. Alright, so how many events occurred? You had the flip of the coin, and then you had a ball being drawn. Those are the 2 events. Do you notice that in our tree diagram, we have 2 branchings? We have the first branch, which is selecting the box after you flip the coin. So here is the flip at the first branch. The next branching going down either path is when you draw a ball. So it's your draw. Okay? Now, we're building a tree diagram because it allows us to look at events as they occur. First there was the flip, then there was the draw. Now this helps us because it keeps our events independent of one another in one sense only. Now, after you flip the coin, that determines if you're in box 1, notice I used B with the subscript 1 here, or you're in box 2. Going down each path, I'm going to keep track of the likelihood, the probability of that happening, and a coin flip is 50-50, so it's 1 out of 2 and 1 out of 2. Now, if we went to box 1, right, if we had a heads, in that box we have 2 red balls out of the 3 total. And we have 1 blue ball out of the 3 total. Do you notice that I'm only looking at this branch right here? Do you also notice that this branch isn't the probability of red ball, it's the probability of red ball given, in other words, because we're on the first branch. When you're on the first branch, you're in box 1. That's why we have written here, given box 1. Which is different than if you'd had a tail on your first flip. The probability of getting a red then is given box 2. Alright? So the question was asking, what is the likelihood of having a red ball? Well, red ball is dependent on being in your first branching or being in your third branching for your overall branches. It's the probability of box 1. It's the probability of getting red given box 1, which is a half times 2/3. Notice I'm just multiplying going down the branch, which is 2, 6. And then it's the same thing, except it's box 2 and red, right? So probability given. And then if I add those 2 outcomes, I would end up with the probability of red.